All right. Sorry about the delay. Had to get chalk brushes. How's everybody doing?
Good.
You guys completely destroyed with midterms?
Yeah, they're coming up.
Well, the lecture today is kind of a bit on the lighter side compared to what we've been doing. So, yeah, it's kind of like, you know, a lower week for us. Although, I'm gonna like go through the Git stuff kind of in summary because like, yeah, I'm sorry about being sick. I couldn't, I just couldn't, you know. It occurs to me that the course has been set up rather unforgivingly in that respect. Like, I don't know if we're going to get through all the assignments, guys. Like you guys have handed in 3, and like there are supposed to be 13, unless we start doubling up, which I don't think anybody wants to do. I think we're gonna have to let that out a little bit. Honestly, I think probably like 10 assignments is plenty, but if I spot one that looks particularly stupid, we'll skip it. Like assignment 3. It kind of sucked, didn't it?
Yeah.
Yeah. I'm in the process of grading them. I'm hoping to have everything off my plate by Friday. So, yeah. We should start by introducing assignment 4, though.
6 close.
Yeah. That's why I got no submissions for it. Makes sense. How was break week otherwise, though?
Needed.
Needed? Yeah. Have you guys ever heard the story of why there is a break week in the fall semester?
No.
Because there wasn't always.
Why? Is there an interesting story behind it?
Yeah. Let me just get my password. Oh, come on. If you think my password is unreasonably long, you're right. I'm not sure of all the details, but the thing I heard was that the fall break was introduced after a student at Waterloo committed suicide. So, yeah, and then basically every post-secondary institution in the province got a break week. So,
I was going to say sanity, but
yeah, no, so, Waterloo is kind of a crazy, crazy place. You know, they have like a very like well-deserved international reputation for mathematics, right? It's kind of interesting. You know, did you know that Waterloo wasn't always called Waterloo? Back before the First World War, it was New Berlin. But they changed it to something sufficiently English sounding during the war. So it's Kitchener Waterloo, Lord Kitchener, Battle of Waterloo. How can you go wrong, right? But yeah, it's where all the Germans settled, and you know, Germans are reputed for being good mathematicians, so that's what their school is all about. But it's like, it's kind of crazy. There's this interesting thing that occasionally happens to human beings genetically, where like they don't require sleep, or at least they can make do on 2 or 3 hours of sleep. This occasion, like it's rare, but it does happen. apparently that's like one of the qualifications to be a professor at Waterloo. And, you know, as the professors are, so they expect their grad students to be, right? So, yeah, it's quite the place, quite the place. When I was teaching at McMaster, sometimes they'd say, "Oh, we gotta compete with the Waterloo guys," and it's like, "You idiots, you can't compete with the Waterloo guys. Do you want to die?" No. But yeah, anyway, it's like, there are some things that just aren't worth it. Just be happy you're going to McMaster. So, assignment 4. Part of the point today is going to be reviewing what we did previously, because that wasn't 1 week ago, that was 2 weeks ago now. Man, this is actually a really good argument for like taking this 4-hour block and chopping it into, because like, man, if I'm sick like one day, you know, like I was only sick that one day. If I'd had another class, we wouldn't have been quite so badly off. I'm gonna bring this up with the administration, but not that that helps you, but you know. Although, I probably could get this this class split. It would just, you know, be 2-hour class and then another 2-hour class after that. So, once again, you're making a video using all the things. Demonstration video should be under 15 minutes. Task 1, basic Git operation practice. While this example is very similar to what we did in class, don't copy the example exactly. Choose your own directory, file, and branch names, and explain what you're doing at each step. So, open the bash shell, use bash for everything. There's a reason this course shows you how to do things in terminal first, right? A lot of this stuff you can do, like, for example, using the web GUI on GitHub, but like, if you want to script it, it's got to be in bash, right? So, you guys need me to go through the list? Or can you guys read it? Yeah? Okay. Alright, everybody seems confident? Okay. Task 2. Challenging branch merge. Oh, you know it's a problem when challenging is in the title. So, before starting this task, download and unzip groceryapp.zip. This zip file contains a grocery app Git repository. Remember, you know it's a Git repository because the folder contains the hidden .git folder where all of the Git stuff is held, right? So you can actually take like a Git repo, zip it up and send it to someone. That's a thing. So, check what branches are in the repository. Explain what happens when you attempt to merge the edit feature branch into the master branch. Explain what happens when you attempt this and why it happened. So, does it go well? No! A problem occurs. Explain the problem. Go through the grocerylist.html file that results after step 4 and explain the contents of the file, including what has been changed after step 4 and what it means in detail. You don't need to use VI unless you want to. You have to use Vim. No, I'm kidding. You use, whatever you like. Nano, Visual Studio, whatever you want. If it were me, I would probably use Nano. Because you're going to be like bopping in and out of terminal really quite a lot, right? After making modifications to grocerylist.html, try to complete the merge again. Your attempt should succeed. So basically, you're given a Git repo that will cause a merge conflict if you try to merge this branch into main. Have it attempt to do so, fix the merge conflict, and attempt to, merge everything back together. The modifications you make to grocerylist.html should make sense and preserve the complete possible functionality given the changes made to the code in each branch. So, I haven't done this, but it kind of sounds to me like 15 minutes is being very generous. Depending on the complexity of the file, you should probably be able to accomplish this in 6 or 7 minutes of video, I would think. This doesn't sound like it's that much. Especially if you've practiced it before you start recording, right? Okay. Any questions? I need the files, please. Don't forget to upload the files when you upload your solution. Upload your video. If you upload the video with no files, you'll get the points for the video but not the files. If you upload the files with no video, you'll get the points for the video, or the files but not for the video. The points for the code are 10, so please submit the video. Otherwise, there's not much I can do for you. All right? Any questions? Yes.
I didn't like where like the video is not on the file, because like every time I try submitting it to the file, it'll just take like too long, or like it won't like, it's just gonna be like a tiny bit of like uploading. So I just put like a link from the YouTube there. Can I just do it like that?
Absolutely. Yeah, when I say upload the video, I also mean include a YouTube link. That's also fine. In fact, actually it's kind of like, I was wondering, like, do I prefer the YouTube one? See, the YouTube one auto captions you, So I might actually prefer YouTube, but
Yeah, because when I tried uploading the assignment before,
yeah,
on the zip, it was either showing like, I think what, like few, like was it 6 or 5 GB or something?
yeah. If the file's that big, like compress it down to an MP4 before you
Yeah,
attempt
if
that.
you try that, it basically just reduce it by like few, like tiny, like by 1 GB or something, or KB or something.
Yeah. If you're trying to upload like a big fat what's like .mov file or whatever it is. Yeah. If you transcode it to MP4 before you upload it, that'll make it go a lot better. But YouTube will take anything, so YouTube's probably
I
simpler.
think it's quicker in YouTube because I converted, but even then like it just doesn't do that much, just does like a little bit.
Yeah.
And that's for like a 7 minutes video or something.
Yeah.
For like the 15 minutes something, it might just take like a few days just to submit it.
I mean, Canvas will cut you off first.
Yeah, it just cuts it off.
Is that that glitch still happening with Canvas where you can't upload things sometimes?
Yeah.
Has anybody had that?
Yeah.
That's still ongoing?
I think it's like a connection issue, it was saying like it wouldn't let me like load it or something, or after it's been loading for a while, just has some connection issue, it just redoes it for me from start.
It's nice to see that ticket is being addressed promptly. All right, everybody, let's grab our Linux. Grab your Linux, unless you're already in Linux, in which case, just chill. You have earned the right to chill if you already run Linux. So yeah, today's agenda, we're going to go over, we'll do actually it's going to probably end up looking pretty similar to your assignment. Going to go through the basic Git operations. After that, we're going to talk about GitHub, right? I'll show you how to make, how many people already have a GitHub account? How many people do not have a GitHub account? All right, since you're like literally the only person that doesn't, would you mind making one?
Yeah.
Yeah, thanks.
Yeah.
It's actually, it's an actual literal part of the slides is to make sure every student in the room has a GitHub account. Good. And then we'll make a repo, we'll check the repo out, you know, we'll clone it. I think the slides are a little out of date, actually. I think GitHub's changed its authentication method since in the last like year or two. So I'll be sending a little buzz to Kevin about that.
Do we just make it with our personal accounts,
Just make it.
or is this a specific to school account?
I think
The intention is for you to use it for a while, I think. So I would link it to your like. Actually, it doesn't even matter because GitHub allows you to link it to several email accounts and like phase email accounts out as they come as they become inactive. Like GitHub runs fantastically. It's like if you want to know what the state of the art in security and validation is, look at what GitHub is doing. All right, let's get this thing running. But yeah, and then I've got a slightly dry set of lecture slides about licenses, software licenses, which I'll try to keep interesting. Are you even working? Yoo-hoo! Yes? There you go. You woke up. I can't do anything until we got this. So. There we go. Isn't it tight? Oh, one more pet peeve about the videos. Please close this pane. All right. Yeah, okay. We have Git. So, can you see this at the back? So, quick review. Working with Git repositories. First, we're going to create a Git repo. There we go. By the way, it will bring a little bit of joy to the cold, cold recesses of the hole that used to be a heart if I see you guys separate your tasks in your videos by doing that.
What if we just clear the console instead?
That also works. But like some kind of like visual indicator of what part you're on. Some people have been like closing the terminal down completely and bringing up a new one, which is also like, that's nice. It's nice. Presentation, you know? So, does anybody remember what command we use to create a new Git repository? Git init. Very good. Git init. And then we provide the name of the repository we wish to create. My repo. There we go. you'll see that we have my repo created as a directory within the folder. You will see that the directory is empty, except of course, using the A flag to view hidden files and folders, we see that we have .git. If you delete this, that means that this isn't a repo anymore. Make sense? Very good. So, yes,
So
question.
what did dash A mean?
Dash A stands for all.
Oh, okay, yeah.
So it's view hidden files and folders.
Oh, okay.
Another common one with ls is L. Well, there's nothing in here, except, there we go. So L is your list view. That gives you your file permissions, sizes, dates of modification. That's L is like your detail view. Very good. Tell me something I don't know. I will. When we get to GitHub, a folder does not get stored unless there's something in it. That's an interesting thing to know about Git. So if you create a directory, directory foo, and then you try to check that in, it will say there's nothing to check in. It needs to have a file in it in order for it to exist. This is why when you create a GitHub repo, the first thing they ask you to do, would you like to put a README or something in there? Like, put something in this, please. It's like, well, yes, it has to do that actually, because otherwise the folder doesn't exist. Right? Very good. So, good. So we have a repo. We now, and I apologize, I'm going to use nano, like the painful normie that I am. File1.txt. This is a watermelon. Save, exit. A file with some contents. How do we commit our changes? That's right. First, we have to add everything that we've changed to the repo. Git add. You can state the file individually, but the most common practice is to use dot. Can anybody remind me what dot is in a Unix environment? Well, in this context, it selects everything. If I were to use that as a file path, what does it mean?
Google State Folder or back?
2 dots goes up 1 level. What does 1 dot do?
The context.
Yes,
The current directory.
the current directory. This is a shortcut for the current working directory. Just where I currently am. That's good to know, because, other commands use that too, like find and grep. So, recall, we can view the status of queued changes and unqueued changes. Actually, let me make another change. File2.txt. This is also a file. Git status. You can see from our status view, we have changes to be committed, new file, file1.txt, untracked files, file2.txt. If I were to modify new file, it would tell me, basically this is like diffing what's in the, what's currently queued for change versus what is currently there versus what's not changed since the last commit, right? Git status, very, very useful. So far so good? Any questions? Good. This is useful, right? Good, all right. If at any point I'm not being useful, let me know. So, let's add that one too. Now, how do we commit something?
Git commit,
Commit, that's right.
dash
-m, very good. And you give a message. If you forget -m, it will pull up your default editor, which I believe most of you should have Nano. Some of you with your own installations will probably have set your default editor to whatever you prefer. But, like I'll show you. If you just git commit, it brings up Nano, and this is where you write your commit message. You're not allowed to not have a commit message. First, commit. Yay. Save it, exit. There we go. Up to the end of the last class, we haven't talked about pushing this to a remote repository. That's what this week's material is all about. For now, that's as far as we got, right? Make sense? Would you like a brief review of how branches work? Cool. So, right now, within my repo, we just made a commit in branch main. We can check using git log. There you go. There's our first commit. You can see that it is in branch main. Does anybody remember how we create a new branch?
git branch and branch, new branch name.
Yes. Git branch, and then you enter the new branch name. Let's say it's dev. Remember, 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 it is the height of poor manners to break your main branch. People expect main to be functional. Like, this is kind of like, you guys have heard of software as service, right? This is kind of like this idea that, it's related to this idea of DevOps, development and operations. Your software should always be in a state, your software should always be in a state where it works and someone can download it, right? The way we used to handle this was, well, we have the zip file of 17.3.72, go and download the latest version, right? That's an awful way to do things. It's much easier if, a package manager can go and fetch the latest version when the latest version is needed, right? If you're using a Git repo to distribute your software, instead of having a bunch of download links on a web page, you need something stable to present to people at all times, and that is what main is supposed to be. So if you break it, you're fired. Okay? Especially if you're at a big company. Don't break main. I mean, you might not be fired, but let's just say that you and being fired came in very close proximity, right? So, what we've just done is we have created a new branch, dev. Currently, there are no commits in it. It's just a branch that exists, right? if you just use git branch itself with no new branch name specified, it tells you what your branches are and also where you are in them, right? Yes.
So like, since we are not connected to GitHub, is there a specific reason why our current branch is named master, and then when we connect it to GitHub, it's named? What's
So-
the difference between that?
Yeah, that's actually, we have something about that on a slide. Main is more inclusive language than master. GitHub made this change in 2020. Git has not yet made this change. That's the reason. Git is like so stable, I'd be surprised if it gets many updates at this point, you know? I could be wrong. It's like highly, highly stable though. Yes, so how do we change branches?
Git checkout.
That's right, git, checkout, and then you specify the name. We want to go to dev, switched to branch dev. You can see that we are now located in dev. So far so good. So now let's make some modifications and create a commit in the dev branch. Now file 1.txt. This is a file, not a watermelon. Right? Very good. Git status. We can see that this has been modified. Incidentally, like, the messages that Git gives you are very good compared to a lot of like Linux terminal stuff, which can look like very fluffy, you know, or it's like, well, that's just a big wall of numbers. I can't even decipher that. That looks like 30,000 URLs to something. I don't even know, right? This is what the Linux experience often is, but this is different with Git, all right? If you're new to Git, it's really strongly worth reading the messages that it gives you, right? For example, use git restore file to discard changes in the working directory, right? That's easy. That's nice to know, right? Yeah. Sometimes when I'm doing like work developing a bash script, I'm like playing around with commands like sed. Ooh, I have to talk to you guys about your assignments in that respect. But yeah, like sed can be very, very destructive, right? So it's very, very, it's a very, very good idea to back things up on Git. Commit everything before you test a sed command, because then you can just restore when it destroys things that you didn't intend to destroy. Yes, and then git add, git commit, corrected watermelon nonsense. All right. So, I would like to take a moment and parenthetically discuss your assignment where you guys had to use VI to make modifications to a file. I believe I'm still in the process of grading these, and I think it's Canvas has done that stupid thing again where it like doesn't hide the grades as I'm marking them, but. So. When you see something that looks like this, I forget which way does the slash go for sed? Is it a forward slash? I think it's a forward slash, right?
Yeah.
Yeah. For a sed pattern. This guy. Right? I saw a lot of this, to my horror, alright? Because one of the parts of that assignment, right, was delete, the lines containing this, that, and the other from your file, right? But it wasn't just like delete the lines containing these things. It was specific. It was like within the context of this object, delete these 3 lines. The ones containing like Mike, Sally, and whatever, right? What people gave me, to my horror, was this thing with a regular expression that specified Mike, Sally, or, Mary, thank you. That deletes any line in the file containing those names, anywhere it occurs, in the whole file, right? Now, I know that it might seem like I'm being nitpicky, right? But there's a very, very strong difference between deleting things in one location and deleting things in every location, right? Like, imagine if that had been over your operating system that you had done that. You could easily brick your computer, not like using sed and not knowing what you're doing. Like if that thing had been given pseudo privileges, that could brick your operating system right there, reinstall, right? So be a little more choosy, all right? So I gave people honest to goodness mark deductions for doing that. And the only reason I could think of that people did that as opposed to the obvious thing, which would be to put your cursor on those 3 lines and delete 3 lines in one command, right? That's the obvious way to do that, right? It was actually like fairly easy for me to tell like who's paying attention in class and who's getting the chat bot to generate their answers, right? Just on that point alone. It's like you have the easy one that's clearly discernible from the class material, and then you have like some kind of convoluted thing using a regular expression that would definitely damage that file if that file were any longer than it was, right? It was a toy example. The line was only like, the JSON was only like 10 lines of code, right? Ish. What if it had been 3,000? Right? What if you didn't know where all of the occurrences of Mary, Jane, and Sally were in that file? It might not even parse as JSON when you're finished. Right? It makes a difference. Right? Don't use commands if you don't know what they do. Okay? There. I'm finished my rant. Oh, but like, and then if you use this method again to like do the replacement on like the second one, which like change age 30 to 40, like you actually just replaced everybody who was 30 in the whole file with 40. Like, don't use global operations unless you need to, okay? It is important. I'm trying to do you a favor by telling you this, all right? Okay? All right? I'm probably preaching to the choir, but but like this is a thing that the bloody chatbot does, right? This is what it does. It overlooks the simple, obvious way of doing something and gives you like a complicated, convoluted thing that does the wrong thing instead, right? So like just, again, don't press enter on the command unless you know every part of what that command is doing. Unless it's creating a Docker instance. Because they're very complicated. But that's why we have Docker files. Alright. Have you been lectured sufficiently? Alright, I want everybody to say, I'm sorry, Professor Moore. Thank you. Alright. So, where were we? Ah, yes. So we've created our commit on the dev branch. There we go. So, fun fact, if we merged dev back into main right now, we couldn't possibly have a merge conflict, right? We would just be able to go like, zoop, zoop, whoop. And like we could even ignore the fact that this even happened, right? We still have we don't really have a branch, right? We've just kind of, stepped to the side for a commit, that's all. This situation changes though, if main has a commit as well, especially if that commit interferes with the change that we just made. I am about to create the deadly and dreaded merge conflict. So, in order to create the merge conflict, we'll need to switch back into main, git checkout master. There we go. Git branch. We are now in master. I need main. Git. Now we want to make a change. Nano file1.txt. This is a watermelon. I don't care what they say. They are haters. There we go. So, we now have a change in file 1. It will be in conflict with the change made in file 1 in branch dev. Let's commit it. Git add, git commit, confident assertion of fruit. Genus. There we go. Oh, I was just about to do it. So now we have one here, one there. Git log all graph. There you go. We have a true and authentic branch. So far, so good. Now, let's smash them back together. So, we are currently in main. We want to merge dev here. Does anybody remember how to do that? The operation term is merge, but what do we specify? We specify the branch that we are merging into this one. There we go. Git merge branch name, in this case, dev. Auto merging failed, file1.txt. Merge conflict in file1.txt. Automatic merge failing. Fix conflicts and commit the result. So basically, when this happens, you are put in the following state. You are here. your goal is to produce the next commit. The next commit must have merge conflicts fixed. So, how do we fix a merge conflict? You look in the file. This is what Git inserts into a file when it has an irreconcilable merge conflict. It tells you which branch has which version, and it says, I am but a poor, humble, simple computer. I don't know how to read human. So human, you're going to have to fix this. And so you do. You have to make the arduous decision. Do we go with this version, where the file confidently asserts that it is a watermelon? Or do we go with this one, which states that the file is not a watermelon? This, in some cases, may be a watermelon. It's up to you to compromise. Most of the time, it should be like fairly obvious which version is the correct version, just from like age. But you can imagine that this might get to be a right royal pain in the keister if this was programming source code that you had to deal with this with. Which it will be, because what do you guys again? What do you do for a living? You program computers. So, in many cases this will be programming source code, and you will be required to decide, for example, which two versions of an if statement do you need, right? Stuff like that. Make sense? Question?
What happens if the merge became successful? In this case, mine made it successfully merged.
Oh, the line numbers must have been different. So, you know the diff program that we talked about previously? That's what it's using in the back end. If diff detects an insertion, rather than like a line change, then it can merge it successfully. Same thing with a deletion. The conflict must be on the same line number in both files. But it's like slightly intelligent. It's like with an asterisk. It's a little bit intelligent about how it does it, right? If it detects like an insertion here, right, it doesn't have to be the same line number. It can be the line. It's the line number after the adjustment from the insertion over here. Stuff like that, right? But yeah, you must have had to put the two modifications on different line numbers, or in different files. This is actually why one of the things that you try to modularize your code around is like different people being responsible for different files, right? Because if two people are working on one file, you can end up with situations like this. But if two people are working on like a different non-disjoint set of files, merge conflicts are basically they only occur if someone's like not staying in their lane, you know? Hopefully this makes sense. Good. Any questions? All right. I don't think we quite made it through all of the slides last time, so I'd like to just take a quick look at the slides to see if there's anything important we missed. It's like 100 slides in this. But most of it is like this, so. Yes, good. Thank you. Yeah, okay. We'll pick it up here. So, conflicts. Workplace conflicts are not fun. Conflicts in file, less fun even than that. Whoa. So, fixing merge conflicts is not an enjoyable activity, but it is part of your job as a programmer. So you must be able to do it. It requires, reading other people's code, which is awful. Even worse, it might require reading your own code, which is doubly bad, because at least when someone else's code is bad, you can be like, oh, that person's an idiot. But if you're reading your own code and it's bad, it's like, oh, no, I'm the idiot. Which is, it just opens up a whole new can of worms. So you're not creating something new so much as fixing something that's broken. Making new things is fun, fixing broken things is bad and hard. Teams develop workflows intentionally to minimize conflicts. I kind of already alluded to this. But they are inevitable, and you will need to learn how to solve them. Here we go. So, what happens if we want to view an old version of something in the repository? This is new information. Perhaps we want to go back and inspect old code. Well, version 2.3 didn't have this problem. Let's go back and see what version 2.3 was doing. How was it handling validation or whatever, right? We can use git checkout, but specify a commit ID. So this is where we come into the idea that the git history is a full and complete history of all changes made to all of the files at all points that you had a commit, right? If you have a commit, you can always return there, right? So, okay, I'm gonna do it on the repo that we've been working on. Oh, wait, I forgot to add and commit these changes. Sorry. Git add dot git commit yes. Sorry. Fixed merge conflict. Git push. No! So close. So close. Alright. Git log graph all. There you go. You can see we've now achieved the final commit. There you go. But let's say that we wanted to view what was going on here. Question?
Did we cover the graph and all flags last class?
Possibly not. I think we did.
Could you cover them again?
Okay. Sounds good. So, graph. So, I'm trying to explain this without explaining the mathematical definition of a graph,
Fair.
Do you want the mathematical definition of a graph? No. Okay. It's a collection of vertexes and edges. So these are all vertexes, these are edges.
So it just displays it?
Yeah, it's the map,
Cool.
right? So it's just like the lines here. If you don't use the graph option, then you just get, you know, the stuff without this thing on the side. There you go. And you can see that we're actually getting all here anyways. Like I guess if there's enough of it, you wait. Am I in dev at the moment? That's a question. Am I still in dev?
Maybe we're back to map search.
I think we're back. Yeah. There's like a way where you view only like the commits made in like the branch you're in. All is the opposite of that. It seems to be set by default though. Maybe that's like an older version or a thing or something. Or maybe like it's like, oh well, I'm intelligent enough to know that you've used graphs, so you probably want to see more than just this line. But yeah, does that make sense? Very good. So if we want to view the state of the code, say on this commit, I don't recommend typing this out manually. Highlight, right-click, copy. That's how you copy things out of terminal. Git checkout, right-click, paste. Certain fancier terminal applications have keyboard shortcuts for this, but Control-C will just like insert characters, you know? So, there you go. You are in detached head state. You can look around, make experimental changes, and commit them. And you can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch to retain commits you create, you may do so, now or later, using the C with the switch command. For example, git switch C new branch name, C for create. Or undo this operation with git switch minus. Turn off this advice by no, we like your advice. We like your advice, Git. So, head is now at this guy. If we say git log, there we go. Git log all to, there we go. All right, so there's a good use of all for you. If you've gone back through the history, git log without all just gives you the history up to this point. With all, you get the future commits listed as well. There you go. So you can see this is the current state of main, this is the current state of dev, and this is where we are in head. Make sense? So far so good? Any questions? Git, and then we can like ls, you can see we have file 1 and file 2, cat file 1, and you can see we have the original version of the file available. Make sense? Very good. Yeah, and now we're done those slides. Sound good? Let me just say that if you are checking out old historical versions, you are probably in deep doo-doo. All right? Most of the time, you'll be wanting to like revert like maybe 1, 2 commits. But if you're having to dig through this, something has gone deeply wrong, and it has unfortunately become your problem, and that's the state that you're in. So, any questions? All good? Good, good, good. All right. Molto bene. All right. I kind of want to start with the licenses, and then we'll do GitHub. Yeah? It's shorter. All right. I'm going to do it. I'm the prof. You got to do what I say. I mean, you don't have to do it. You know what I mean. If I don't have autonomy over what slide I present first. All right. So, let's talk about licenses. This should be more interesting than you might think it will be, actually.
Excuse me?
Question?
Before we go ahead,
Yes.
assignment,
You have a question?
the assignment 4 is closed, are you gonna open
I just opened it. I think. Assignment 4? Is it still closed? It says it's open. Oh, the due date might be wrong. Yes, let me check. Let me fix the due date. Ah, yeah. Clear that. Let's see. Get her in by, what's today? 20th? Get her in by Sunday? Yeah? Good. There we go. You should be able to see it now. Of course. So, licenses and README files. So, welcome. So, software licenses. Unfortunately, this is like, we're gonna have to talk about like copyright law and that kind of stuff. So, historically speaking, when software was first developed, it was developed by companies primarily, and these companies sort of applied to it the standard way that they dealt with intellectual property, right? Which is to say, the software we developed for this doodad, right? This is proprietary software. This is our software that we wrote. Nobody else can have it. It is, in fact, the use of the software that we are charging for. And that is how things worked to a great extent prior to the open source revolution. So, it's actually kind of fascinating. Has anybody ever wondered why there are so many versions of SQL? You guys want to hear? Yeah. So, back in the 70s, this is how you would develop software products. One company would develop a specification for a particular piece of software. They would license that specification to other companies who would develop implementations of that software. This is the same process by which C, the C programming language, was originally distributed, right? So, it kind of all depended on how good your spec was. The spec for the C programming language was very good, very tight, didn't leave much room for ambiguity. So, you ended up with a small number of C compilers that all do fairly equivalent things, right? Can anybody name the three big C compilers? C# is not a C compiler.
C++.
No, GCC and Clang.
GCC, Clang, yes. So GCC is the GNU compiler collection. That's the one that's associated with Linux, right? Clang is IBM, I believe. And the third one is the Windows C compiler. Two of these are compliant with the C specification. One of them is not. I'll leave you to figure out which one is not. The SQL specification had a lot more wiggle room in it. So what companies generally did with these looser specifications, they'd add additional things to the language, additional features, they would call them features, and that would be like their unique selling point of like the Oracle version versus like the, whoever else had a version, right? And that's how it worked, right? Complicated, fairly complicated system, right? But that's the reason there are so many SQL implementations, some of which are open source. The open source ones are winning, by the way. Do you guys know what the most popular SQL server at the moment is? Any guesses? Postgres is correct. Second is MySQL. Both of those are open source. So, a license specifies what others are allowed to do with the source code. Can the source code be used as part of a commercial for-profit application, for example? So what on earth is open source software in the first place? It is source code. It is software where the source code is distributed publicly with a license that specifies how it may be used, modified, and further distributed. So it is not true to say that open source software is distributed without a license, right? This is perhaps an increasingly common misconception. The software may be given out for free, but if you want to take it, modify it, and even charge for it commercially, sometimes that's permitted, sometimes that's not, under the license. So, permissive licenses have less restrictions on usage, modification, and distribution. You can imagine that something proprietary, like the source code for Microsoft Office software, if you were to yoink that source code, make a few modifications, and then, distribute it for money, Microsoft is going to nuke you out of existence with sky lasers, right? You will be in lawsuit city. However, this is precisely what you can do with more permissive licensing structures, right? So, the collection of these, this is a loose collection of different license types. The general term for this is copyleft, right? So, copyleft as opposed to copyright, right? We're not that, we're the opposite of that. But you still need some form of licensing, right? Copyleft licenses generally specify that source code derivative of the original source code must use the same license as the original, right? So that's like one of the major provisions for copyleft software, right? Basically, if it started open source, it must remain open source according to the license. You're not allowed to take open source software and close it down as, make modifications, close it down as proprietary source code, and then charge money for it. You're not permitted to do that. It must remain open source if it started open source in most cases. This doesn't mean you can't charge money for it, right? In some cases, you can charge money for it, but it must remain open source. So the question then becomes, well, what are you paying for, right? If I can compile the source code, right? What do I need you for? If the source code is free, why do I need you? And The answer can be a couple of things. Number one, compiling it can be non-trivial. You might just be paying for the binaries. That occasionally is true. But also, you're basically paying for the software as service kind of angle, right? You, company, or person, do you find this software useful? Would you like it to have additional features in the future? In that case, you need to give me money for it, right? You pay for the software, and the developers use that money to not starve so that they can continue to develop that software. Does that make sense? You can only get so far on people's goodwill and, spare time, right? You can get a certain distance on people's goodwill and spare time, but eventually, as we all know, software becomes sufficiently complicated over time that you want to have paid people who work on it, right, as their actual jobs. Yes. If you build an open source project with copyleft licensing, anything that uses it must also be open source. A former Microsoft CEO famously referred to this by saying, Linux is a cancer, in that open source encourages more open source. And to that I have but one reply. Let's hope it kills the host. A couple of famous license types. The MIT, Massachusetts Institute of Technology license. This is commonly used as a permissive license that essentially lets you do anything you like with the source code, so long as the original copyright and license notice is kept in the software. So, again, it is open source and must remain so, but you can basically do anything you like with it, right? The GPL license, GNU Public License, you'll find a lot of core Linux stuff is released under this license because, GNU compiler collection, GNU public license, right? Have you guys ever seen the GNU, right? He's like a mascot character, no? I don't have to show that. You guys can look it up. GPL is a family of licenses with various versions. If you use GPL licensed components, your software must also use the GPL license and must also become freely available. So GPL, you're not allowed to charge. MIT, you can. Question?
Yes. MIT, are you able to just, if it has an MIT license, are you able to just sell that for profit? Because it says specifically in GPL that it must become freely available, like it's even listed, but is that not the case for MIT?
Yeah, that's you're picking up on the correct distinction, yes. Under GPL, so the acronym that's been used lately to describe this is FOSS, Free and Open Source Software, right? So under GPL, you're not permitted to charge money. It must remain free. That also doesn't mean you can't make money off of it, but must remain free. Whereas with MIT, it's more permissive than this in an odd way, right? You're not restricted from making money off of the thing that's under an MIT license. Developers like the GPL license because it means that their volunteer open source, all of their contributors will basically be volunteers. It will not become commercialized or sold for profit. Well, it doesn't necessarily mean, it depends on what you mean by commercialized, right? There are lots of companies that pay people as their jobs to develop things under GPL licenses. A good example of this is Debian, right? What's Debian?
It's a Linux derivative.
It's a Linux distribution, yes. It's not just a Linux distribution. It is the root of yes, definitely the most popular family of Linux distributions. Ubuntu is Debian derived. Mint is Ubuntu derived and therefore Debian derived. If I go to DistroWatch, I think I can, I can tell you. DistroWatch. There we go. Where's your most popular? Come on. You're killing me, DistroWatch. Weird. That's interesting. Where's the? Weird.
News and reviews.
Visitor rankings. Yeah. Okay. Weird. Anyway, right now, you kind of have like three main like families that are competing for dominance. You have Debian, which is like the safe choice. That's how Debian is so popular and like how it gets. That's why it's as popular as it is. It's the safe choice. You have Red Hat, right? Red Hat is like the corporate one. Like you can pay companies for like Red Hat support, and that's like how they make a lot of their money. Like that's their whole business model is like you have a company contracts for like tech support for the Linux distribution, right? So it is possible to monetize, right? You just can't charge for the software. Fedora is like the personal version of Red Hat Enterprise. You then also have the Arch family, which is some of the new ones like MX and Cashy are Arch based. It's like that's the one that the nerds use, you know. Yeah. Do you mind telling us which distro you use?
Me?
Yeah.
I use Ubuntu right now, but I did used to use Arch, and then I used one called NixOS.
Oh yeah. That's like a small one, right?
Yeah.
Yeah.
I ended up swapping to Ubuntu because in Arch I had to mess with, I think it was called Pipewire, to like, I couldn't stream my audio on Discord or something like that. I don't remember. It was just weird swap.
See, this kind of perfectly exemplifies what I'm talking about, right? Like Debian, because it's like the biggest one, it attracts the most like hardware and like drivers guys, and like companies actually pay people to develop on like Debian and that kind of stuff. So normally very stable, and like, you know, a lot of the like traditional like Linuxy hardware glitches that you end up with, Debian, it's the least bad for it, but Arch does some like very interesting stuff too. But yeah, you know, that's kind of a reason to have all. That's part of the reason there are so many is because like, you know, it's an ecosystem. It's an ecosystem. It's the rainforest. Anyway, where are we here? Yes, there we go. So, when you're creating a GitHub repository, you can select a license to be used. When you create a new one, you get a drop-down list, right? GNU General Public License version 3, MIT license, a couple of BSD ones, Creative Commons. Creative Commons is like not normally one that you see applied to software, but you usually see like other sorts of things, sometimes software. A license file containing the license will automatically be added to the repository, conveniently enough. So, we're going to discuss forking repositories later, you know, when we talk about the rest of it, but a fork is where you have a repo and you're like, I want that, I want to do my own thing with it, but I hate the people that are working on this, I don't want to work with them. That's a lot of the time. One like very famous fork was, so the standard so the standard Office software set that you get with Linux is, like, there are two of them. There's OpenOffice and there's LibreOffice, right? I believe it's OpenOffice, which is the good one.
I use LibreOffice.
Do you?
Yeah.
I forget which one is which. It says on the Wikipedia though. Yeah. Okay, yeah, so OpenOffice was succeeded by LibreOffice. Yes. Yeah, I'm remembering it now. So, in tech writing, do they still have that assignment where they can ask you to compare this to, like, Word, right? Are they still doing OpenOffice and not LibreOffice?
I could be.
Yeah?
Yeah.
Okay, good. Because that was like, at one point, it was like, everybody was like, well, clearly Windows is superior, because like they were comparing, you know, basically the old dead project that hadn't been developed in like many years. Or it's still like, I believe it's still under active development, OpenOffice, but like basically anybody who had any talent left, like, because I think they were doing something with the licensing or something. So yeah, notable fork. LibreOffice was forked from OpenOffice. And like anybody with any talent worked on LibreOffice, and that's why it's the good one and OpenOffice is the bad one. But I always mix up which one is which. But yeah. Yep. So, when users fork a repository on GitHub, they'll get the same licensing file. This can ensure that work you create is attributed back to you and gives you some control over how it is used and modified, etc. So one thing that you commonly see in licensing for these things is you must credit the original author, right? Makes sense, right? Like, you can use this, you can even sell it, but you gotta give me credit, man, you know? As a practical matter, keep in mind that people break the rules. If someone included your source code in their commercial application, could you even prove it? Right? That is also a problem. You know, not to mention, it's time for the professor to take his glasses off and rub the bridge of his nose as he talks about AI. I have seen the chatbot referred to by Dinosaur Comics, which is a webcomic that I read. I've seen it referred to as corporate global hyperplagiarism, which it is. It is plagiarism. It's trained on largely open source software because that's the one with the source code available, right? And do you think it's respecting the licenses? Nope. I don't think so. So, you know, do people break this rule? Mm-hmm. Do algorithms break this rule? Mm-hmm. Can you prove that software was or wasn't written by the chatbot? They decided not to solve that problem before they went live with it. That would have been a good problem to solve, but I think it's actually fundamentally unsolvable. So, readmes. It's It's in the title of the file. It is the file that you should read, period. The README. When creating a GitHub repository, you also have the option to add in a README file. So on GitHub, these will be markdown files. GitHub will actually automatically take the markdown formatted README and render it as like web page underneath your hierarchy view of the contents of the repo, which is kind of cool. You can always add a README later if you did not add it when the repository was created. So, what is the purpose of a README? Anybody?
So if you have a project, it just the description of how the program is going to be run or how it's going to be set up.
Yes. So normally, if nothing else, installation instructions, right? The README should contain installation instructions. Now, how complicated installation is it varies. If your software requires any specific environment variables to be set, you should have included a setup script that sets them for the person who's downloading it, right? You should have an installation script. But if you expect, if you haven't encoded that in a file that'll actually do it, the README will include all of this information. What needs to be true about the environment in order for the software to run? I'm speaking from personal experience when I say that, right? It's like, well, your environment variable should be set to this, and blah, 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 blah. It's like, you can do that. All you have to do is write a script to do that. But no, you expect me to set my own environment variables. Good grief. Just keep in mind, if your software requires people to set environment variables, it will not be runnable by anybody who does not know how to set environment variables, which is like, I don't know, if I were to guess, how many people are on this rock again? How many people are on this planet? Like 8 billion, right? The number of people who know how to set an environment variable is probably less than 1 million, actually. Maybe a bit more than that. Nah, I'm going to say 1 million people on the planet probably know how to set an environment variable. Less than you'd think. So, when you create a repository, you can create it with a README file, in which case all you have to do is fill the thing in, boom. Of course, this falls under the title of documentation, right? In addition to installation instructions, you should also include, what is this software? What does it do? What does this project intend? Right? Yes. Good. The README file will be placed in the repository and you can edit it. Once we get there, you'll see that we can edit things right in GitHub, although I'm sure everybody already knows that actually. Almost everybody. Notice how we have the Octothorpe repo name by default to start with. In this case, the repository's name is temp. This is Markdown, right? This is how you do a heading in Markdown. Number of Octothorpes gives you the degree, like whether you're an H1, H2, H3, basically. Here's a guide for Markdown, and here's the thing I just said. One is like an H1, H2, H3. This may not actually correspond to those headings in HTML, but it's close enough approximation. Good. A few more basics. For Markdown, double asterisk, bolded text, underscores on either side, italicized text, blocks of code using triple quote, triple single, I think that's backtick, isn't it? Yeah, triple backtick, just like that, and links, square braces and round braces with the link. Another fun little thing about Markdown, you can include LaTeX formulas. LaTeX formulas natively. Although you probably don't care about that because like I'm the only person in the room who likes LaTeX. Probably a lot of you have never even heard of LaTeX. LaTeX is what I use to make my tests. And my slides. And everything. Because anything that was made on Microsoft Office software looks like it was made by a child. Yes. So for bulleted lists, you can use minus, asterisk, or plus on individual lines. You can do nestedness by tabs. And you can use 1 dot, 2 dot, 3 dot in order to do numbered lists. So you can see this is kind of a compact form that gives you many of the options that HTML gave you. You can also do things like tables in them easier than in HTML. And that's it. Very good. Any questions about any of that? All right. Okay, and now I'm going to show you my favorite README of all time. All right. Oh. They renamed it. Oh, that's a shame. It used to be called Dreambird. So, but it's been renamed to Gulf of Mexico. I guess because the Gulf of Mexico was renamed, so somebody needed it. The name was free, so they decided to take it, right? This is the perfect programming language. The perfect programming language. Exclamation marks. Instead of semicolons. Right? You can use as many as you want. Be emphatic. If you're unsure, that's okay. You can use a question mark instead. So you're wondering if semicolons are exclamation points, what do I use for exclamation points?
Semicolons.
Semicolons. If not false. There you go. Hello world. So, there are 4 types of declarations in this lovely language. Constant constants can't be changed in any way. Constant variables can be edited but not reassigned. Variable constants can be redefined but not edited. And variable variables, which can be reassigned and edited. This is a joke language. But it does have a compiler. So you can't actually write programs in this. Yeah. Oh, and immutables are constants. So there you go. Some languages start arrays at 0, which can be unintuitive for beginners. Some languages start at 1, which isn't representative of how the code actually works. So this language does the best of both worlds. Arrays start at -1.
Genius.
Oh, and you can use floats for indexes now as well. So there you go.
Oh no.
Let's see here. Something else. Oh, yes. So for Booleans, you can use true, false, or maybe.
Maybe.
Yeah. Now this is an interesting one actually, because you think this is a joke, but this is actually less of a joke than you might think it is. Some languages do actually have a maybe type. Rust has a maybe. Because Rust is like drawing inspiration from the functional language paradigm, which is like Haskell. Haskell also includes a maybe type. So like in a strongly typed language, it's like the solution in a strongly typed language, how do I do a null, right? And how do I do null properly in a like well-typed way? It's like, well, you create a new type that's either null or it's the value, and that's a maybe type, but it's a wrapper for another type. But yeah, anyway, this is just a joke, but you know, I thought it was funny. Oof! So, Gulf of Mexico has significant white space. Using space to specify the order of arithmetic operations.
That's awesome, actually.
That's actually not a completely terrible idea. Except that it would be a terrible idea. Yes.
In execution.
It's, yeah, but, oh. Fractions. You can also use the names of the numbers. Okay, I'm gonna stop this madness. If you want, that's my favorite README of all time. If you guys want to read through the rest on your own time, I highly encourage it. All right, we're gonna call the break then. When we return, we shall talk about GitHub. I hereby declare a 1/2 hour break. 31 minutes. I'll give you. Oh no, there you go. Nope, you get 30 minutes. Please be ready to resume class at 5:50 p.m. Thank you. It's the class, right? Yeah, we actually have like next week's material is on making a portfolio website. So we'll leave a certain amount of that discussion for that. But here we go. Okay. So, necessary word of caution before we launch into this one. It's in the back of my brain that the way GitHub does authentication has changed since these slides were produced. So that is something we're probably going to encounter when we attempt to do stuff. But everybody has a GitHub account? Yes, everybody? Excluding no one? Good, because you'll need one to do the assignment. Good. I know it's owned by Microsoft. I understand your reticence. I share it. Fun fact about me, at one point I was actually like paying for GitHub. Back before they made everything free. Before they made everything free, you had to like pay a small subscription to have private repos. And now, Microsoft basically just harvests the data from everything, and that's their income in Minecraft. So far, we've had all these, all the stuff we did, all the stuff we reviewed at the beginning. I hope you guys didn't mind that that took like an hour to do. I hope that was useful. So Git allows us to collaborate with others using remote repositories as well. This is like, for me personally, even if it's a repo only for my own private use, I still put it up on GitHub. Because collaborating with other people, it's useful to be able to say, hey, why don't I just let you into the Git repo? There you go, you can just do that. Further, sometimes you have more than one computer, right? It basically doubles as cloud storage, right? But like good cloud storage that keeps good backups, right? I've kind of gotten to the point where I don't keep anything important not in a repo, you know? Did I tell you guys the story about the TA I had who tried to vandalize my my grade book?
Yep.
Yeah.
Yeah, exactly, right?
What
So-
an nincompoop.
Sorry?
What a nincompoop.
Yeah, just like complete ne'er-do-well. Oh man, I'm actually blanking on terms of that. Anyway. So, Git itself does not require a central server to work. Git can work on a distributed model, similar to the multiplayer in Dark Souls 1. A peer-to-peer network, as it were. However, by convention, virtually all Git team workflows use a central server because that's just very useful, right? It's very useful to have one central location where everything, the official copy is stored, and if that location, you know, if you don't have to check everyone in the network, you only have to check that one location to see if there's an update, and so it goes, right? So, distributed version control system. You might have 3 people or workstations, each one having a working copy of the files. Each one has their own Git repository. Those are synchronized with the central repository in the server. I personally use this because I have my own laptop, which is my personal property. I also have a work terminal that has been given to me by the school. I have this set up, and this is how I make sure that the thing I was working on at home, I'm like one command away from having all the latest work I was doing. You don't have to email yourself stuff. If you're emailing files, don't. Use a repo, okay? I sync things up using Git repo so that I always have the most up-to-date version on both ends. The only thing is you will occasionally forget to commit your changes, right? That's like the thing, is you gotta get good at remembering to commit your changes. But, if you're a real person with a real job, you should be in the habit of that within a week. Because I'm a fake person with a fake job, it takes me a little longer. The job is real, but it's for a fake institution. It's not a fake institution. Let's just keep going. Sometimes you start a tangent and anyway. So, college is not the real world. That's what I was trying to say. Despite physically existing in real space. So, team members will each have a local repository on their own machine. You will have one, and you will have one, and you will have one. Team members will download the code, pull, and they will upload code, push, to the central repository in order to coordinate. While it is possible to set up your own central Git repository server, using a service is widely adopted because setting up servers is a specialized skill that not everybody has invested the time in exploring. Like, everybody in this room can set up a server, right? You guys can set up servers, You just need to you just need to learn how to do that, right? The barrier is learning how to do that, right? But it's like you have the aptitude. If you've gotten this far, you have the aptitude to set up a server. So, GitHub. Yes. Bitbucket. Another one that's common is GitLab. Can I think of any others? Don't use Dropbox. For God's sake, don't use Dropbox. Does anybody even use Dropbox anymore, or did that die 10 years ago? Hopefully it died a terrible, painful death. It was like this application that would like sync one of your Windows folders on a Windows machine to other folders on Windows machines. It was attempting to do this, but poorly and on Windows, which is to say poorly. So, we're working with a remote repository expands the number of commands that you have to use. Basically, there are like 2 important commands and 1 less important command. The important ones are git push, which pushes the local repository to the remote repository. Git pull, which pulls the remote repository down to your workspace, right? Cloning is the same process. We also have git fetch, right? So I suppose first we should explore what each of these little disk areas are. So workspace, those are the files and folders as they exist on your hard drive, right? When you modify files, that's where the modifications go. The staging area stores everything that you have git added, right? When you check git status, you are comparing what's been staged of the changes and what hasn't. First, what are the changes? Second, how many of those have been staged, right? Number 3, your local repository. This is your .git folder, right? This is where all of the changes are tracked. Develop your file, git add, put it in the staging area, git commit puts it in the local repository. By the way, git commit with the A flag, does both at the same time, there you go. And then once things have been stored in your local repository, you push them forward to the remote repository. That way all your friends can see it. Question?
Why would you, because I see that git commit -a is available, what necessarily is the point of the staging area?
Well, to a certain extent for legacy reasons.
Okay.
So, like, there's actually not just git add. You've also got move, remove. These, like, you can go into a thing and just like remove this file, saying git remove file, right? The alternative way of doing that is to remove it using rm and then stage that change using git add, and then you commit it, right? So yeah, like your question is kind of like, why do we need the individual like sub functions that a function calls when we have the function that calls them?
Oh, I see.
Right? Yeah. Question?
My co-op used the staging environment for testing,
Yeah.
extensive testing.
Yes.
My job.
So, good show. It also depends on like, what is the nature of this thing?
Yeah.
Is it master or is it main? Because if it's main, you might not want to just go ahead and push it, right? You might want to do some testing first. We're actually going to get into CI/CD towards the end of this course, so we're going to use GitHub Actions. So there are reasons to break things out, but you know, for our purposes, this will work most of the time for most cases. Good. All right. 4 important new commands, as I stated. Git clone creates a copy of a repository. Git fetch downloads updates from a remote repository, but does not merge them with the local repository. So basically, if we go back, git fetch pulls from remote to local, but it does not modify the workspace, right? You get to choose whether you modify the workspace. This will come in, this will again be useful in more complex workflows. But you know, we're kind of, because this is a class, we're kind of like at a more basic level, right? The idea is that this gives you enough knowledge for you to be able to plug other pieces of knowledge into it, right? So, git pull downloads updates from a remote repository and merges them with the local repository. So, this is the one that you will use mostly, probably most of the time. It just, I want the server version. Grab, plunk, and now I can start typing. That's what that one is. Git push uploads updates from local repository to remote repository, but of course only works if the local repository has the changes. You must commit before you push. Otherwise, you're not pushing anything. Make sense? Any questions so far? These are the main ones. So, let's talk about GitHub. GitHub is an extremely popular service for hosting Git repositories. It's definitely the case now that you're on GitHub unless you have a good reason not to be, right? For example, when I was working at the university, I was doing stuff with GitHub, and it was like I was asked to switch to the department's own local GitLab server, which they had, and it's like, well, you know, fair enough. If they want to own it on premise, then that's fine, right? Also, GitLab at that time, this may have changed, but at that time it had a slightly less problematic permissions system for what we were trying to do with it, so it made a few things easier. Once again, different tools for different jobs, right? But, yeah. Many students will host side projects they've created on GitHub and use their GitHub account as a portfolio. How many people in this room have side projects? Good. The rest of you should get side projects. They are extremely useful for getting jobs. Companies that hire students will seek out this specifically and ask about projects during interviews. It's part of your portfolio, all right? I was talking to a student who's in an earlier semester who I've been, kind of giving some of this information to because he's bright and interested in that sort of thing. And he showed me his Git repo, and it's he's got a project in there, and it's it's fairly small, but it's there. And I'm with the weathered eye, I'm looking at his the GitHub landing page shows you a graph of how many commits you've made to something. I'm sure lots of you have seen this, right? I'm looking at it and I'm like, Okay, so you did this in one weekend, right? Maybe give me something that you had to work a little harder on for a portfolio project, right? Like your git commit graph actually becomes like a direct measurement of how much effort did you put into this, right? So if you want to be hired by people, it's good to look like a person who puts effort into things, right? You're not just trying to tick the box, you wanted like a good solid project, right? So like finishing it in a weekend is probably means it's not complicated enough. And as I stated this earlier, but GitHub replaced the term master for its the main branch with main for repositories hosted with them in 2020. Although I think if you have a repository that dates back to before that, it might still have the old name, but I forget. Maybe they went through and fixed it. I'm not sure. And that was because that was for inclusivity related reasons. So many GitHub repositories are public repositories, which means that anyone can pull, unclip, or clone from them. If it's a public GitHub repo, it is open source, period. Right? Now, in order to prevent complete and total chaos from ensuing, not everyone can push to everything that's public, right? You can pull, but you can't push. You can't vandalize other people's code, right? Your account either needs to be added as a collaborator, or you can do what's called a pull request. We will discuss pull requests. So, if you want to take a look at Kevin, that's Kevin. Hi, Kevin. This is Kevin's GitHub repo. You can see he's got some public repositories there. Yeah, you can see how much he's been committing. Let's see here. Let me see if I can find mine. Yeah, there I am. 10 points if anybody knows who that guy is.
Dungeon Man.
There we go, you get 10 points. Video game?
Earthbound.
There you go, very good. So yeah, a little bit of stuff. This one is actually my thesis. Oh guys, do you want to see my like thesis project that I did for my PhD? For my yeah. So ooh, I gotta show you the main one. You can tell I was kind of getting a little, you know. So this is a language called Haskell. This goes on for quite some time. 4,000 lines of code. And this is Haskell, which is like a hyper-dense language. You can accomplish in one line of Haskell what would take you probably 20 or 30 lines in like a normal like C-like language. I tallied it up, and like if you took everything together, you're probably looking at like 150, 200,000 lines of code-ish in a normal language. But yeah, it's murderous. It is murder. This language is murder. Don't ever use it. This is a compiler. I wrote a compiler in Haskell, guys. Like, oh man, where's the top level one? Can't even find it anymore. I'm getting mild PTSD right now. Yeah, that'll be it. All right, kids. This is what file I/O looks like. No, sorry, not file I/O. This is what standard, like, writing to standard output looks like. Like this is me taking like command line arguments right here. This is like the put stuff. This is the stuff where you put stuff. Yeah. Anyway, I hate myself. That's why I did this project. Okay? Guess how long I worked on it for?
8 months.
10 years. Yeah. This was in continuous development for 10 years. Which is longer than most of you have been alive. Actually, that's not true. Like, I've been finding like the classes kind of weight pretty heavily towards like people in their mid to late 20s, actually. Yeah. All right. I'm gonna stop having PTSD now. Yeah. So this is one that we're gonna like pull and do some stuff with HTML basics. It was awful. Don't ever do a PhD, guys. They're not worth it. So, yes. So if we take a look, if we click on a repo, lots of people I'm sure have seen this before. How many people, well, I'm just gonna do it. This is a repo page, all right? You've got lots of different stuff here. This is a view of all of the files and folders inside the repo, right? This is the button you click to get the code. You can, if you're a chump, download a zip file, all right? But if you are a true programmer, you will know that you'll want to clone the repository using your own installation of Git because you're not a chump. It is also possible, and I kind of may even recommend this over the original, like the version of this that will appear in the slides. GitHub has its own command line tool, GitHub. It is where they've been like putting a lot of their authentication stuff in. So like there's some stuff that I think you can't do without it anymore. Or if you can, it's very convoluted. So this is what we're going to be doing, okay? GitHub. So, and of course, GitHub desktop, if you want this interface, but like on your own local machine rather than like on the remote repository. But yeah, you can view the contents of these files. There you go. Level beginner. There you go. There you go. So, a fair amount of this course the remainder of this course is gonna be going through these tabs. This one in particular. This GitHub Actions, this is how you do automated testing, which is, yeah, we'll get into it. That's like, when people are saying stuff like, you know, on like a job description, like CI/CD, you can like say, well, I know how GitHub Actions work, does that count? And they'll be like, yes, that's precisely what we're talking about, thank you. That's good enough. Basically, a lot of these kind of DevOps-y-ish tools, if you know how to use one of them, you probably know reasonably well how to use its competitors, right? It's kind of like this thing where like, you know the three major cloud vendors? Who can tell me the three major cloud vendors? Sorry? AWS is one of them. Azure is another one. And? Google. Yeah. Oracle, you know, maybe fourth place. So yeah, the general assumption in industry is like, you don't have to know all three, right? But like if you, basically like a certification in Azure is seen as a pretty good indication that you could figure out Google without too much trouble, right? Like the knowledge is considered transferable, right? Yes. So, where are we here? So, let's clone this repository, and let's do it in sort of the normal way without the GitHub command line interface. You need the URL. The URL is github.com/username/repo name. Nice and simple. Copy. Repeat after me. Git clone. Oh no. Ah, it's a different clipboard. Ah. Alright, I'll type it. https://github.com/ProfKevinBrown/HTML basics. .git. Don't forget the .git. Otherwise, you won't get it. Ha! So, you can see that happened rather quickly. Cloning into HTML basics. Done. You can see this creates a new directory within your file system, HTML basics. That is now the cloned repository. CD HTML basics. There we go. So, those are all of the files as they appear here, right? Now, if I do something like this, nano vandalism, Kevin is a big nerd. There we go. You can see that my file containing vandalism occurs in the file system. Note, it does not automatically reflect changes here. Further, well, we haven't even committed it yet, right? So it wouldn't. But I can add it. I can commit it. Lols. There we go. You can see it permits me to commit the file, right? I have committed vandalism, right? So, although I have committed vandalism to my own local repository, if we try to push that vandalism up, git push, uh-oh, starting to ask for a username. Username, who's asking? Password. Authentication fails. Obviously, like, even if I had entered my own proper username and password, I wouldn't get anything here, right? I don't have permission to push to this repo. Presumably, only Kevin. Make sense? Unless he's added collaborators. So far so good? Any questions? Very good. A lot of software, like open source software projects, like on their downloads and installation pages now, will just say, here's the link to the Git repo, or here's the GitHub link. You know, basically, if you don't know how to work with that, you're not worthy of our software. Which is true. So, one interesting thing to note here is that we don't just get like the current iteration of things like you would with the zip file, which is another reason why zip loading, like downloading the zip file is wrong and bad. Well, actually, it might be including the Git folder now that I think about it. I'll retract the previous statement. It's still bad to download the zip file though. You still get all of the history, right? The history of all of the previous commits. And you can see who has been committing things. So you can see the most recent commit is from tooltime, right? Then from Kevin, author, did we make that commit? How many times did we commit, guys? Right? And did we make that commit in February? Right? From our machine. What machine was this done from?
A VM.
Yes, Kevin was using the VM to push to the repository in February. So there you go. And you can see this has like a fair... It seems like he was using this to teach. So, yeah, quite a lot. There we go. And we get to know all of that. It's actually been kind of like floated around the department that one way we can kind of step up our anti-plagiarism measures is to just get everybody to have to commit to Git repos so that we can check the Git logs to make sure they didn't dump their entire assignment into the repo all in one piece, you know? So, good. So, origin. The term origin refers to the repository from which this one was originally cloned. So origin is the one on GitHub. If we could say git push origin to push changes to the remote repository, but git push already pushes to origin. Like this only makes a difference if you're having to push it to other, like in a decentralized Git, right? If you had like person A, B, and C, you would have like a routine, presumably, that would like push to B and C if you were A, right? Yes. We can list all remote repositories available using git remote. Again, that will be more interesting when you're not using the centralized server way of doing things, right? If you want the list of all remote repositories, like if you were wondering how it is that Git manages a distributed network, peer-to-peer network of Git repos, well, you can see all of the remote repositories and you can push to them, so that's how. Yes, I already did this. Yes. Well, there's an interesting one. Git push origin will also not work if he uses his own username and password. Authentication failed. Support for password authentication was removed on August 13th, 2021. I remember the day. I was like, wait, I need what to log in? Because, well, that's not actually true. I had it set up a month ahead of time, but there were a lot of people on that day who were quickly scrambling for their passkeys. So, Git does not support access control. The repositories themselves are not password protected, right? Basically, they're only protected by what you, where they're located on your file system, right? So if you're, if you have two users on your machine, right? If you you can't view someone else's files, right? It's you're locked out of them. So you also can't view someone else's Git repo, but if you have a Linux computer with two users, like my laptop, which has a user for my wife, because she does occasionally need to use my laptop, but famously, I do not share my root password with her. Not even my wife. And she's like, oh, I would use your computer, but you won't give me your password. And I'm like, yes, I'll make you an account. That's how that's supposed to work. You can do too much damage with my root password. She does not have sudoing privileges. But that's mostly because she has no idea what that even means. So, there you go. So, we're going to skip this because everybody has one. Thank you. So, let's create some repositories. If you have not currently done so, please log in to your GitHub account. I shall do so within the safe sandbox of this VM. I'm going to delete at the end of class. I suggest you do the same. You guys don't need to know. You guys don't need to know how many characters my password is. Here we go. So, a little bit of a peek behind the curtain here. Guess what, guys? I'm not going to show you that. Yeah. Yeah, as you can see, yeah. I want to show off my Git, my yeah.
I can get it during this.
Yeah, there you go.
I got it exactly.
You can see oh come on, I've done more than that. I guess those are just the big ones. It's like I have a semester where I'm only committing on like Tuesdays. Yeah. Yeah, there you go. I've been more I thought I had been more active. Certainly. Oh, there's a scroll bar. Why is there? I've got it zoomed in too far. That's why. There we go. Yeah. Anyway. New repository. Repositories. New repository. There you go. So you can tell, like, I actually do use this. Huh? Why is this like? Is this like because Firefox is out of date? This might be goofing up because Firefox is out of date. Anyway. So, this is the Create New Repository page. How many people are located here? Thumbs up? Yep. Okay. I'd like to just like parenthetically take a moment to talk about authentication. For some time, it has been the case that things prefer you to do SMS two-factor authentication. That's going the way of the dodo. A much better and more secure way of doing that is to use an authenticator app. It turns out that HTTP is more secure than literally like radio broadcasting your code to literally everybody in the area of your cell phone tower. So yeah, I use the GitHub Authenticator app personally, and I think you guys should too. So, let's make a new repository. This repository's name shall be made for a class. There we go. Description. Yes. So, configuration. Choose visibility. This is important. If it's public, you are releasing as open source software. If it's private, you get to choose. Right? I think in this case we're supposed to do it as public, right? Let's see here. Yeah. We're going to be making these ones as public repos. So, make it public. Add a README. Sure. Git ignore. We actually have this is a topic that we're going to be discussing in a couple of weeks. So we'll kind of put a pin in that for the time being. Basically, it's just a file that contains glob patterns for file types and string matches that you want to not include, right? It's used, you know how whenever you compile something, there's always a billion auxiliary files that are always made, right? You don't have to save them in a Git repo. You can set a Git ignore rule to ignore all of the file types that aren't important, and that's what that's for. It has pre-configured ones for a lot of different different types of things, like a lot, right? Including bloody Agda. You guys, okay. You guys want to know what Agda is?
Sure.
You know Haskell, the extremely abstruse language I showed you that I wrote my PhD in? Agda is a version of Haskell where you cannot, in theory, you cannot compile the code unless it contains a proof of its own correctness. It's impossible to write anything. Trust me, I tried. It's like, if you want difficult, obscure languages, right now for me, Agda is like the most difficult and obscure language that you can possibly think of that isn't like a meme language. So, anyway. So you can choose a template. I'm sure they have LaTeX there. LaTeX. What? No? Not enough. You can choose the license. We talked about licenses. Let's do GPL. There you go. Create repository. Boom. Question.
When you make it private, can people see your commit history? So let's say you said we should have, before applying to a job, we should have a history of all of our commits to show during an interview. If you make your project private, is there a way to show that?
They show up in the graph.
Okay, they do. All right.
Yeah, like, I don't think I've... I apologize.
Yes.
I don't think I've made a commit to a public repository in like 4 years. So,
Yeah.
like a hair in my mouth or something. And so, like a moron, I decided to try to wash it down instead of gagging. So, there you go. Brand new, brand spanking new repository with nothing in it. You can see the contents of README is just like the name of the repository and the description you gave it. You can edit this. There you go. Thousands of Boffins died to bring us this info. I don't think they ever say in the movie what a Bothan even is. Presumably some type of person from some, like maybe people from the planet Both. Both seems like a funny name for a planet in the same universe that has the planet Hoth. Hoth and Both. Maybe they're like in the same star cluster. Anyway, commit changes. It gives you a commit message. You can commit the changes. You can add more information if you want. Create it on a new branch. You have the option. Commit changes. Boom. And there you have it. Clicking on this, you can see your different branches. There you go. Make sense? So, you guys know Gilbert? Professor Gilbert?
The really old comic.
Yeah, he's kind of tall and he kind of talks like this, you know? Yeah, Dave Gilbert. He and I were like collaborating on a test for database theory using this, and like he was like, well, I've not really used GitHub very much, and I said, there, just make the account and see, and you can use the web GUI if you really want to. He was like, yes, that's sufficient. I will use the web GUI. I don't want to have to install anything. It's like, yeah, okay. And then we collaborated, and it was great. It's the best collaboration ever, because it used GitHub. It was fantastic. It's like, every time when I say to people, please give me some questions for the test, and please give it to me in plain text format, you'd think people who teach programming would know what please give it to me in plain text means, but most of them don't. I hate words so much. Alright. So, yes. So now, let's get this thing and pull it and clone it in the proper way. Shall we? So first things first, we're going to have to install GitHub, the command line interface. So sudo apt update. Yes. What? Come on. There you go. You stupid machine. It's okay, you can call Linux a stupid machine because it knows it's a stupid machine. It's not pretentious that way. Git apt install GitHub. What? Oh, yes. No. Yes, I'm sudo. There we go. GitHub is already installed. Oh, thank you, Kevin. Oh, there we go. So, if you take a look in a book, there you go. Get the code, local. You have options for HTTPS, SSH, and GitHub CLI. GitHub CLI is the one that we want. The command for it is gh repo clone, and then a slightly contracted form of the URL. Click. There we go. Paste. Welcome to GitHub CLI. To authenticate, please run gh auth login. So logins using this can be set to be persistent so that your computer is always logged into your GitHub account. If you're careful about your password for your user account, this is probably fine. If you're a bit more security conscious, perhaps you want to authenticate every time. It's up to you. It's up to you. You want your it's the traditional security versus convenience trade-off. Well, however you want to fall on that is fine. Unless it's too far in favor of convenience. gh auth login. There we go. So, what account do you want to log into? Well, we're just github.com, not enterprise server, so there you go. What is your preferred protocol? Probably HTTPS. Just use HTTPS. There you go. Authenticate Git with your GitHub credentials. Now this, basically, you should only do this on your own machine, right? Don't do this on a public machine, okay? But you probably do want Git authenticated with your GitHub credentials. Otherwise, you'll have to re-enter them every time you want to use a Git command. Or at least every session. So, in my case, I'm going to say yes, but only because I'm intending to destroy this VM as soon as this class is over. And it's sandboxed inside the VM. Yes. So, how do you want to authenticate? Log in with the web browser or paste an authentication token. You probably want to log in with the browser because that's easy. First, copy your one-time code. Copy your one-time code. I probably shouldn't be showing you that. That's okay. Press enter to open GitHub in your browser. Verify session. There we go. I am signed in as. There you go. Continue. Enter the code. Boom. Continue. Authorize GitHub. Yes, please. And you're done. That authorizes it. And that is much easier than using the way it worked before was like you had to like go into like the settings page and generate a validation token and then copy that into the like the command line interface, and it was like, it wasn't awful, but this is much easier. They've improved the system. So there you go. Now, authentication complete. Press enter to continue. Logged in. I'm now logged in. It's kind of interesting to think of yourself as being logged in a command line interface, but you know, modern problems require modern solutions. Now we can clone the repo. Boom! And that works for private repos too. So far so good? Any questions? Alright. Good. So, now that we have a local copy, we can actually use the commands. CD made for class. Nano file.txt. My goodness, this took a while. Save, exit. At file.txt. It has contents. There we go. Now, again, just because you've modified the file locally does not mean that any changes have been pushed to the remote repository. You must do that yourself. Did I show you guys the in case of fire thing? No? Okay. There you go. In case of fire, git commit, git push, leave building. So, git, whoa, git add, oh, it's because it's small. There we go. Git add, git commit, changes, git push, git push, and it pushes it. Now, if we take a look, reload the page, file.txt is now in there. Very good. We can even modify it. GitHub wants you to use this pane as like an actual coding IDE, but you probably prefer VS Code. Save. So Control S for save is actually commit here, right? Boom. There we go. If we want to see those changes in our local repository, git pull. Cat file.txt, the changes appear. Right? It's very important to understand when I'm interacting with the repository here, I am interacting with the local repository. It's in the local file system. When I am working through the browser, I am not accessing the local file system, I am accessing the remote repository on the server. I know okay. Hopefully I don't have to make that distinction, but it's still, like, some people find it confusing. So, yes, good. So it is also possible to take a local repository and push it up to GitHub where it wasn't previously on GitHub. Right? That's what this process is for. So let's imagine that we have a repo such as my repo, right there. In order for GitHub to accept it, we need to rename the master branch to main. This is the command for that. Git branch capital M main. Wait, am I in the repo? You gotta be in the repo first. CD my repo. So another thing to understand about like using GitHub from the command line is that it's very sensitive to where the current working directory is. So in order to do anything with the repo, your current working directory must be inside of it, right? You must do it from within the repo. So git branch m main. There we go. In the branch name. Oh, wait, am I in? Let's see here. Let's do this. Git branch. Yeah, I remember. I was in detached head state. Git check out master. Boom. What? Come on. Yes, there we go. Branch. There we go. Now, that one. There you go. We have renamed master to main. Now it's compatible with GitHub. Next, we need to add the origin remote server to the GitHub repo we wish to push to. So for example, git remote add origin, that thing. So, git remote add origin github.com/me/. Made, let's try made for a class. There we go. Now, no errors, so that's good. Git push u origin main. Oh, dot git. Yeah. All right. I think it wants you to like make a new repository with the same name and then push it. Yes. You'll still it also may like I think the slides might be like this might be a symptom of the slides not using like GitHub, like the GitHub command line interface. That seems like the way that you would do this these days. So how about we just put a pin in that one? I'll take a look, and next time we'll see if we can't get that working. Oh, yes. Don't recommend any of this information on authentication. We've already done this. Yes. like, you know, do the way we did it. Don't, you can still mess around with like the tokens, I'm pretty sure, but if you don't have to, then don't, basically. Our text file should then be added on. Yes, we did that. Yes, we did that. Yes, yep, we did all that. Commits. It would be useful to see how you get to the commits screen. There we go. Oh man. Does anybody know where they moved that to? Anybody know how to see the commit history here? Maybe it's like, yeah?
There's like a history button. You can even say, it says 4 commits in the top corner by 7 minutes ago. You see and more, where it says updated file.txt.
And more updated. Oh,
Yeah, if you go on
Oh!
the same row, you can see the commits.
there we go. Thank you.
No problem.
So there you go. You can see your commit history. Who's committing what at what times, right? Very useful. Slightly nicer to look at than the command line interface, I will admit. Yes, 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 yes. So, by default, git pull will attempt to merge changes from the remote repository into the local repository. We can set it to merge only if it is a fast-forward merge. We can also rebase our repository. If you're interested in these, here's a link for reading. In this case, if we had no conflicts and the merge went fine, in this case, we had no conflicts and the merge went fine, pardon me. If we had conflicts, we might need to resolve them as we have done previously. So it is, and trust me, I was there like last week, I was doing this. If you're pulling, like, here's the scenario, right? I make change on my one computer, I forget to commit change, I make change on my other computer. I try to pull changes from one computer into the other, I have conflict. You have to change it, you have to fix the merge conflict the same way that you do if you're making, like, you've got two commits, right, that you're trying to merge together, but it's a little bit more, like the process is a little bit more, like it's got more options and text to read if it's one of these. It'll ask you if you want to rebase or fast forward, right? I've found rebasing works more consistently. Yes. Yes. Yeah. Yeah. So, we've already seen how to fix them, get merge today. Although, all right, fine. We don't have much time left, but we'll do this. So let's imagine that I make a change here. Oh my goodness. That change. Let's say in my local, not this one. This was made, yep, there we go. let's say I say my good NAS. You see I've just created a merge conflict, right? If I now go here, where's GitHub? That's not even a thing. There we go. If I save that, commit it, wait, no, please. Edit. There we go. Commit changes, yes. I think the changes are already committed then. Let's see here. File, yep, there we go. Yes, good. So, git pull. There you go. Error, your local changes to the following files would be overwritten by merge. Please commit your changes or stash them before you merge. So first it says, you gotta commit that. So you commit it, git add, git commit, rupro, git pull. Ooh, the big wall of text. So, hint. Git config pull rebase false. So this is the default strategy. This is merge. Basically, it's saying, you haven't configured me to tell me how to deal with these. So I'm just going to give you this text until you do. You can also, if you don't want to configure it globally, you can also pass rebase or no rebase as arguments to git pull. So, git pull -- no - rebase. There we go. Auto merging. That just does like the normal merge process. You can see it's inserted the git conflict string, etc. Make sense? Then you fix this, you commit it, you push it up, and you're done. Make sense? Good. Let's see here. Oh man. Man, these like 100 slideshows are killer, man. I guess we'll take this up. We'll pick this up next week. Oh well. That's okay. Any questions? Good luck on your midterms. Good night, everybody. Say good night, Gracie. Good night, Gracie.